This is part 8 of the module 10 lecture. In this case, we're going to look at an example where we make an inference about a population variance. So this is the same example that we introduced earlier. So in this example, we have a high volume pharmacy operation where the variability of the cycle time causes some of these prescriptions to be delivered late. So the management wants to use this initiative of the 5 nines, and so that 99.99% of their prescriptions are delivered in time. And based on their calculations, they need to have a variance of less than 20.25 minutes square, or a standard deviation of less than 0.45 minutes to achieve that goal. So the management made several improvements, and then they want to see if these improvements have achieved the level of variability that they need. For this purpose, they randomly selected 31 prescriptions and measured their cycle times. And the data is in this Excel data file that will be posted on Blackboard so you can see it. In here, the first question is we want to determine if the variance of cycle time is 20.25 or less at a 0.01 significance level, and we want to calculate the 99% confidence interval. Now, I underlined this variance must be less than, and here we also said that we want to see that the variance to be less than 20.25, and I think you recognize that alternative hypothesis in this statement. All right, let's follow our procedure. And the first thing we have to do, in this case, they don't give us a summary statistics, so we have to calculate those statistics ourselves. So here are the 31 observations. Well, I couldn't fit all 31 here, so I put the beginning observations and the last few observations. But if you had all the observations and you apply the formula for the mean, you will find that the mean is 12.7419. And if you apply the formula for the variance, if you use this formula and for all these values, then you will find that the variance is 20.5225. In this case, I use Excel to do these calculations. I didn't do these calculations by hand. And of course, in an exam, I'll give you these numbers. I will not ask you to calculate these things. All right, so as before, we need to summarize the information that we're provided with. So the sample size, it should be 31, not 35. I'll make that correction. The sample mean is what we showed in the previous slide, the same as the variance. And if you take the square root of the sample variance, then you have the sample standard deviation as 4.5302. The hypothesized value of the variance under the null hypothesis is 20.25. All right, step one, we need to write our hypothesis first. So remember, they're trying to determine that if the variance of the cycle times of these prescriptions is less than 20.25. So that's the alternative hypothesis. And the null hypothesis will be the opposite statement, so that the variance is 20.25 or larger. So clearly from the alternative hypothesis, we see that this is a left tail test, and the significance level is 0.01. Now, what distribution to use? Well, first of all, the observations in the sample are independent because they come from a random sample. And we're making the assumption that the cycle times come from a normal distribution. Because of these two facts, then we are justified in using the chi-square distribution with 30 degrees of freedom. 30 because we have a sample size of 31 minus 1 is 30. All right, so now we know that we're going to use a chi-square distribution with 31 degrees of freedom. The next step is to calculate the test statistic. We know that n minus 1 is 30. We already know the value of the sample variance, and we know the variance under the null hypothesis, which is 20.25. So you carry out that calculation, and the value of the chi-square is 30.4037. All right, so now we have the test statistic. If you decide to use the critical value approach to make a decision, then you know this is a left tail test. So you go into table 6 and look at the row for 30 degrees of freedom, but now you need to use the complement because this table gives you the probabilities to the right of the value. Therefore, we have to do 1 minus alpha, and alpha is 0.01, so that's 0.99. So if you look at the table and look at the row for 30 degrees of freedom and the column for a probability of 0.99, you find that the critical value of the chi-square is 14.953. So the rejection region is for chi-square values smaller than 14.953. And I'm showing that in that diagram there. All right, so if you decide to use the p-value approach, then we use the calculated value of the test statistic. So again, we look on table 6 at the row for 30 degrees of freedom, and we're trying to see where this value of 30.4037 is. And when you look at those at that row of values, you see that 30.4037 is between the values of 20.599 and 40.256, which corresponds to a probability of 0.9 and a probability of 0.1. So that tells us that the p-value is between 0.9 and 0.1, a huge range of probability. So, but if you use this formula on Excel, then you find that the p-value is 0.5549. All right, so now we have the p-value, or an idea of the range of the p-value, and we know the critical value. So in step 5, we make a decision about the null hypothesis, and you see that the observed value of the test statistic is larger than the critical value, which implies, remember now, we're looking at probabilities smaller than 14.953, and this value is larger than 14.953, which implies that the test statistic is in the non-rejection region. Also, the p-value we know is between 0.1 and 0.9. Therefore, the p-value is larger than the alpha of 0.01. So both criteria indicate that the null hypothesis should be rejected. So, rather, should not be rejected. So the null hypothesis is that the variance is 20.25 or larger. So the interpretation of our decision will be that at a significance level of 0.01, we can conclude that the variance of the cycle time to fill a prescription is 20.25 minutes or larger. Hence, the process improvements did not reach the desired reduction in variance. And very likely management will be interested in seeing, well, how big or how small the actual variance is. We know is 20.25 or larger. So what is that value? So in that case, we use a 99% confidence interval. And so if we go into table 6 for 30 degrees of freedom and for alpha divided by 2, which is 0.005, you find the upper chi-square value of 53.672. Now, if you go back to table 6, look at the row for 30 degrees of freedom, but now you use alpha 1 minus alpha divided by 2. Now it gives you the lower value of the chi-square distribution, which is 13.787. So now, using those values, we can calculate the confidence interval limits. And as you can see, the lower confidence interval limit uses the upper value in the denominator. And in the numerator, we have the degrees of freedom times the sample variance. And for the upper confidence interval limit, then in the denominator, we have the lower chi-square value. And then in the top, we have the degrees of freedom times the sample variance. And that's here's the upper limit. All right, so here's the limits of the confidence interval. So what we need to do is interpret that confidence interval. Also, if you rather express the confidence intervals in terms of the standard deviation, well, what you do, you take the square root of those variances, or those limits rather. And so now you have the limits for the standard deviation. All right, so the interpretation of the confidence interval is that at a 99% confidence level, the population variance of the cycle times to fill a prescription is between 11.4711 and 44.6562 minutes square, Or you can say that the population standard deviation, the cycle time, or the cycle times to fill a prescription is between 3.3869 and 6.68 minutes. So with this, management can see how much their improvements reduce variation. And they can see that their improvement didn't reduce it enough to meet the specified goal. All right, so with this, we're done with this example for making inferences about a single population variance. Again, this is one example, and you can look at the example in your textbook, and you have two examples to see how this is done. All right, with this, we're done with this module 10. And module 10 assignments, there are 3. One that's focused on the goodness of fit test and finding chi-square values. The part 2 is focused on the test for independence and homogeneity. And part 3 is about inferences about a single variance. To see the due dates, just look at the due dates of the assignments or look at the calendar on Wiley+. All right, so at this point, you should be able to know how to find chi-square values using table 6. You should be able to perform a goodness of fit test following the 5-step process and explain the decision of the test. You should be able to distinguish between a test of independence and a test for homogeneity. And you should be able to perform a test of independence or homogeneity following the 5-step process and explain the decision of the test. Also, you should be able to perform a hypothesis test of a single variance following the 5-step process and explain the decision of the test. And you should be able to calculate the confidence interval for a population variance or standard deviation and interpret the confidence interval. All right, so with this, we're finished with module 10.